Most steel beams nowadays come in the shape of I-beams, and you probably see them from cross-section looking like an I. Essentially, the top face and the bottom face are flat and long, but the inside is skinny and vertical. And you might not realize that it has a lot of structural integrity exactly because of this shape, and I'll explain why. But first, we need to just look at how beams deform under a load. So if you have a beam supported on two sides and you introduce a force, then it's going to look like this. Exaggerated, but look at exactly what's happening here in terms of lengths. The bottom is getting longer than its original because it's kind of like pushing out. Like if you were to push a book out, then the outside face would get wider, while the top is getting shrunken in. So we can say that the top experiences compression, while the bottom experiences tension. So if you look at individual pieces on the top, they're getting closer and closer to each other, while the bottom are getting farther and farther away. And an interesting thing is that actually the middle, the very center of the beam doesn't actually change shape at all. Now if you think about it in terms of forces, you can say that there's a lot of inward forces here, while there's a lot of outward forces here, and once again there's just no forces in the center of the beam. And this is true for cantilevers as well. If you have a piece sticking out and then you introduce a force downwards, there's going to be tension on the top and compression on the bottom, and just visualizing like this will help you see that. But right in the center, no force. So what does this mean in terms of beam design? Well, you want more material where there's a lot of force to support that force. And because there's absolutely no force right at the middle, then you don't need as much steel there, because what is that steel doing anyway? You build structures so that the entire material surface and structure of whatever element you're placing there, you should use all of this to keep your building or keep your bridge sturdy, if it's a bridge, or to keep your floor of a skyscraper strong enough that it holds everybody on that floor. And for beams, you see them in all kinds of structures as the frame of your building. So you want both columns and you want beams especially to be able to hold the loads that you might inject onto the surfaces. So since you know that you'll have pretty much equal but opposite kinds of forces on the top and bottom of a beam, you want to add as much. Well, let me draw a cross section here. Without an I-beam, it would just be like a block, like a rectangular prism. But you want you're going to have a lot of force here, and a lot of force here, and nothing here. So for the same amount of material, why don't you just take chunks out of the inside and then bring them outwards to support where you know there'll be more force. So the more area you have up here, then the more it's going to withhold compression or tension, and the same goes for here. And since there's not much happening here, you just need a connection. So that's how I-beams are designed. You have as much of the material coming out to the outsides, so that it's harder for this interface to bend. And then the middle is just a connection. And in fact, for the same amount of volume, you're getting a lot more strength out of your beam.